Greetings. Today, we're going to be discussing menthol. Menthol is an organic compound found across several industries, and you can probably find it in many of your household products. In particular, it's very popular at the current moment due to its interactions with the human body.
Menthol is a waxy, crystalline substance, clear or white in color, which is solid at room temperature. However, it melts around 100 degrees Fahrenheit. It also has a cooling peppermint smell and taste to it. This substance can be found in both nature and made synthetically. The IUPAC name for menthol is 1R2S 5R 2-isopropyl 5-methylcyclohexanol. In total, menthol has 8 stereoisomers. This means it has 4 sets of enantiomers. The naturally occurring form of menthol is shown in the bottom left-hand corner. It is the laboratory form, which means that it's the compound that rotates the plane of polarized light to the left, while the 1 isomer of menthol in the top left-hand corner rotates the plane of polarized light to the right. The structure of menthol has one significant functional group, which is alcohol, but does feature several alkanes and a carbon ring. It also has a 1R2S 5R configuration, which refers to the orientation of its chiral centers. This means that the isopropyl group is in the trans orientation to both the methyl and hydroxyl groups and can be drawn in any of the ways shown. As you can see here, when the compound is in a chair conformation, all 3 bulky groups can orient themselves into equatorial positions. Menthol reacts in many ways like a normal secondary alcohol would. It is oxidized to methone by oxidizing agents such as chromic acid. Although, under some conditions, the oxidation can go even further and break open the ring. Menthol is also easily dehydrated to give mainly 3-methene by the action of 2% sulfuric acid. We can also see that PCl5 gives us menthol chloride when reacted with menthol. In organic chemistry, menthol is also used as a chiral auxiliary in asymmetric synthesis. For example, sulfonate esters made from sulfonyl chlorides and menthol can be used to make enantiomerically pure sulfoxides by reaction with organolithium reagents or Grignard reagents. Menthol is also used for classical resolution of chiral carboxylic acids by using menthol esters.
Natural menthol is found in the peppermint oil of mint leaves. While natural menthol was isolated for the first time by scientists in 1771, the molecule was consistently used in early Japan, dating back almost 2,000 years ago. The most common naturally occurring isomer is negative menthol or L-menthol. The process for extracting natural menthol involves crushing the leaves and then running a steam distillation to extract crude peppermint oil. Once the peppermint oil is obtained crude, the menthol can be isolated in the lab. While menthol is found and harvested from naturally occurring sources, the demand for it is so high that the need developed for a synthetically processed version of the molecule. The Symrise process, formerly known as the Harman and Reimer process, was one of the first successful ways to synthesize menthol using the M-cresol molecule and was first applied in 1973. The key process of this mechanism, pictured in the top right, is the use of benzoate esters to help in the separation of the racemic mixture that is formed in the process. This problem is the core of most menthol synthesis processes. Chemists must figure out how to develop a process that produces desirable menthol isomers, L-menthol, from the racemic mixtures that the synthesis produces. Ryoji Noyori made a major breakthrough in this problem with asymmetric hydrogenation catalysts involving ruthenium. The Takasago process, bottom right, implements Noyori's S-DNAP catalyst to catalyze the addition of lithium amide to myrcene to produce L-menthol. Menthol synthesis is still evolving, most notably in 2012 by the German company BASF. Their BASF process uses terpenes, molecules based on isopentane structures, to synthesize L-menthol from butene.
Menthol works as a counter-irritant which makes it trivial swelling in order to reduce further swelling. This is why you feel a cool sensation and then a warm sensation. Icy hot is an example of this. Menthol will cause redness as blood flow to the area is increased and may also come off as heat as an increase in blood flow increases the skin temperature. Menthol can also cause a numbing effect. This can be found in topical gel and dental care, cough drops, and throat medicines. This numbing effect is caused by menthol binding to another receptor called the kappa opioid receptor. Rubbing menthol causes the nearby blood vessels to widen, increasing blood flow to the area. This is known as vasodilation. Blood carries in fresh nutrients to repair the area and carries away any toxic waste generated. This has been shown to speed up the healing time. Scientists have seen an increase in heart rate when you combine smoking with menthol. It has been shown that nicotine is able to stimulate the nervous system more efficiently with menthol. This essentially increases the addiction to nicotine. According to the FDA, non-menthol smokers who switch to menthol cigarettes increase their rate of consumption overall. Menthol is responsible for the cooling sensation when inhaled, eaten, or applied to the skin. This cooling sensation is caused by menthol's ability to chemically trigger the cold-sensitive TRPM8 receptor. TRPM8 is a voltage-gated ion channel protein which allows the entry of calcium ion. Menthol is also known to take away the bad effects on inflammation. Inflammation means to ignite or to be on fire. Applying menthol on the inflamed wound gives a sensation of cooling by activating the TRPM8 without any actual fall in temperature, thus bringing down the inflammation.
One of the most common applications of menthol is how we take advantage of how it triggers the TRMP8 receptor. This makes it extremely popular because it leaves the affected area with a false feeling of being cool, which we associate with cleanliness. The most iconic use of it is probably in dental hygiene products, such as toothpaste, dental floss, and mouthwash. Every single time we use these products, our mouths are covered in menthol. The interesting part about this means that the ingredient we associate the most with being clean actually does the least amount of cleansing. This is especially obvious in toothpaste, as the active ingredients are just small little granules which scrub away plaque and food. Normally, this wouldn't do anything to make you feel clean except if you were to physically run your tongue or finger along your teeth to feel for plaque. This is the same case in mouthwash. The active ingredients, such as thymol, actively work to kill bacteria, but we think our mouths are cleaner because of menthol, which does almost nothing. This is also pretty popular in candies, such as mints and gum. Upon eating these, you're exposed to menthol, which makes your mouth feel colder. We combine this with the sweet taste of the candy, and we assume that our breath is somehow more pleasant. Another convenient reason to use menthol in these products, in both candy and dental products, is that it has a naturally minty taste, due to where we would get it from, being mint oils and plants, which makes it a very good flavoring agent. Menthol's pain-killing effect actually makes it a pretty popular ingredient among cigarette manufacturers, too. Smoke tends to irritate the lungs and throat, which is unpleasant for smokers. Menthol counteracts these discomforts by decreasing the inflammation and numbing pain. This allows the user to smoke for longer periods of time in relative comfort. Obviously, from a corporate standpoint, this makes menthol very appealing, as it allows customers to use more of their product, and the customers expose themselves to the addictive chemicals of the cigarettes over longer and longer periods of time. Menthol is actually pretty popular within the dental industry due to how it often contains two impurities, which are carvacrol and thymol. Now, I personally think that one of the really cool things about this is how you can actually tell how similar carvacrol and thymol are to menthol. Their only real difference is how they have a phenol ring instead of an alkane ring. Similarly, the only difference between carvacrol and thymol is how the alcohol has been shifted up to so that it's next to the methyl group instead of the T-butyl group. Though I really don't think that this would change how the chemical would interact at all. However, the important part of these chemicals is that they both have phenol rings, which are extremely toxic to a subtype of bacteria, which are referred to as gram-positive bacteria. Almost all bacteria have a cell wall made of a polysaccharide called peptidoglycan. Now, while gram-negative bacteria has several smaller layers, making it somewhat difficult to kill, gram-positive bacteria has one massive and thick layer of peptidoglycan, which is incredibly easy for a single phenol group to just come in and disrupt the molecule, killing the bacteria. One of the more interesting applications of menthol is how it is used as a pesticide in beehives. Sometimes bees are infested with a parasite called tracheal mites. These mites are extremely harmful to the host as they make it harder for the bee to breathe, they make the bee less efficient when they're working, and it significantly reduces their lifespan. For beekeepers, this is a nightmare, as it means that if a hive is infected, the population stops working at full capacity, and their populations are liable to decrease over time. Now, menthol is a fantastic pesticide in these situations. It's extremely easy to apply, as you can just put a bunch of pellets either directly under the hive or you can put it within the hive. In warmer weather, somewhere around 70 degrees Fahrenheit or warmer, the menthol will start letting off vapors. The bees will inhale these vapors, which kill off the mites. Though the reason as to why the mites die off hasn't quite been nailed down yet, the two prevailing theories are that it acts as a neurotoxin or that it suffocates the mites by denying them oxygen. Over the course of about 15 days, all of the mice will die off, while the bees are left completely unharmed. This is similar to how chocolate is harmful to dogs, though for us humans it is completely benign.
Due to the versatile use of menthol, we've had to cover a wide variety of content. If you ever want to learn more about this compound, feel free to use our resources, or to do some research of your own. Thanks for watching.